Welcome to Ellie's Classroom. In just 10 minutes, we'll cover everything you need to know for Unit 1 Matter and Chemical Bonding. So let's get started.
So let's break down the properties of matter. First up, what is matter? So matter is anything you can touch, hold, or see that takes up space and has mass, like air, water, or even your desk. But things like light, sound, or emotions, they're not matter. They don't take up space or have mass. Now let's look at the types of matter. We have pure substances, which are made of only one kind of particle or molecule. They're uniform and cannot be separated physically. For example, water. Water is made of a lot of water molecules. I cannot separate water molecules. On the other hand, mixtures, they are made of two or more substances or molecules and can be physically combined. For example, you have a salad or a cookie or even air. Air is made up of water vapor, carbon dioxide, and oxygen, amongst other gases. So that means it is a mixture. You have a homogeneous mixture, which is the same throughout, it looks the same like milk or air, and you have a heterogeneous mixture, which looks different like a salad or cookies. Last up, isotopes and average atomic mass. Isotopes are atoms of the same element with the same number of protons but different neutrons. Example, carbon 12 has 6 protons and 6 neutrons. Carbon 13 has 6 protons and 7 neutrons. This means they are isotopes. To find an element's average atomic mass, we use the formula given in red, and you can calculate what the average is. We cannot come up with one atomic mass because we don't have one number of neutrons, since we have isotopes.
All right, now what is an atom? An atom is the basic block of everything around you. It is just one tiny particle made of protons, neutrons, and electrons. Think of it like a Lego piece, super small but essential. Now, when you have a substance made of only one kind of atom, that becomes an element. Example, oxygen. A lot of oxygen atoms make the element oxygen. But what happens when different atoms join together in fixed ratios? That's a compound. For example, water. Water is made of two hydrogen atoms and one oxygen atom. Similarly, carbon dioxide, one carbon atom and two oxygen atoms. These atoms bond chemically, and the result is a brand new substance with its own properties. And that's how atoms form elements and elements form compounds. That's the core of chemistry. Let's now discuss some essential periodic trends that you need to know. 1. Atomic size decreases from left to right across a period because the effective nuclear charge increases. That is, the pull that protons have on inner electrons. You can calculate the effective charge by dividing the number of protons over the inner electrons. Inner electrons are the electrons minus the valence electron. Secondly, ionization energy. This is the energy needed to remove an electron. It increases left to right and upwards due to a smaller atomic radius, stronger nuclear pull, also known as stronger effective nuclear charge, and due to less electron shielding. Electron affinity. This is how badly an atom wants an extra electron. This also increases left to right and up the table. There are some notable exceptions for this, and you can look up these values as well. Now, metal reactivity increases going downwards and to the left, while nonmetal reactivity increases up and to the right. Just remember that noble gases don't react. They are chill, they don't do anything. Finally, electronegativity. This is the pull on bonding electrons. It also increases from left to right and upwards. You should be able to master these trends and have them noted in your periodic table. Let's dive into chemical bonding, how atoms stick together. First, we have ionic bonding. That's when a metal and a nonmetal react. One atom transfers electrons to the other. Example, sodium chloride. Sodium gives an electron to chlorine. Then we have covalent bonding. That's when two nonmetals share electrons instead of transferring them. Example, water. Each hydrogen shares its electron with oxygen. How do we know the type of bond? Well, the electronegativity difference between atoms tells us. We have different values telling us different kinds of bonds. You don't need to memorize these will be given to you. Now, molecules have shapes. We use Vesper theory to predict these based on electron repulsion.
VESPR, VSEPR, is an acronym. Water, for example, has a bent shape. Carbon dioxide has a linear shape. These shapes are available to you on the table, and you do need to memorize these for your upcoming tests. Now, polarity. This depends on both shape and electronegativity. Water is polar because it is asymmetric with charged ends. Carbon dioxide is nonpolar because it's symmetric and balanced. Lastly, let's talk about intermolecular forces. These are the forces that keep molecules together, not elements, but molecules together. There are three. We have London dispersion, also known as van der Waals forces. These are the weakest of all, and these are present between all molecules. London dispersion increases based on increasing number of electrons. Second strongest are the dipole-dipole forces, and these are only present between polar molecules. Finally, the hydrogen bonding force. This is the strongest, and it happens when hydrogen is bonded to a nitrogen, oxygen, or fluorine. That's why water sticks together so well, because it has hydrogen bonds. Now that we know how atoms bond, let's learn how to name the compounds that they form. This is called nomenclature, and there are six main types of naming. Binary ionic compounds. These are compounds made of metal and nonmetal. You always name the metal first and then the nonmetal ending with IDE. Example, sodium chloride. Secondly, multivalent metals. That is some metals that have more than one possible charge. These are usually transition metals. For example, iron 2 chloride. Thirdly, polyatomic ions. These are a charged group of atoms. You will need to memorize these names, or you might be provided these on your test. You always name the metal first and then the polyatomic ion. You don't need to change the endings. For example, calcium nitrate. Next, acid-base nomenclature. For binary acids, that is a hydrogen and then any nonmetal, you say hydrogen plus the root name plus IC at the end. For example, hydrogen chloric acid. Then you have oxyacids, that is any acid with a hydrogen plus a polyatomic ion, usually having an oxygen. For example, hydrogen and a sulfate, that is named sulfuric acid, not hydrosulfuric acid, just sulfuric acid. Then hydrates. Hydrates are compounds with water molecules attached. For example, copper sulfate with water is copper 3 sulfate pentahydrate. That is, you add the Greek prefix for numbers before the hydrate. Finally, covalent compounds. These are compounds that involve two metals. You use Greek prefixes like mono, di, and tri. The first element keeps its full name. The second uses a prefix plus a root plus an IDE at the end. For example, carbon dioxide. Another example, dinitrogen pentoxide, since there are two nitrogens. You do not add Greek prefixes for binary compounds. Let's now talk about chemical reactions and how to classify and balance them. There are six main types you need to know. Synthesis, where two combine to make one. Example, hydrogen and chlorine make hydrochloric acid. Second, decomposition, that's the exact opposite, when one thing breaks apart. For example, HCl breaking apart into H plus Cl. We have then single displacement, when one element replaces the other. You can see sodium plus AgCl becomes Ag plus sodium Cl. Sodium replaces Ag. Metal always replaces metal, nonmetal replaces nonmetal. Second, double displacement. These are when two compounds swap parts. You can see HCl plus NaF equals HF plus NaCl. Cl and Na come together, H and F come together. I like to think about it, the elements by the plus sign always get together, and then the other two get together. 5. Neutralization. An acid and a base combine to always make a salt and water. The salt is any ionic compound, doesn't have to be NaCl. Lastly, combustion reaction. You have a complete combustion where you always only make CO2 and water. And then you have an incomplete combustion where you can also make byproducts of carbon, like CO and C. Now for balancing equations, the goal is to make the number of each type of atom equal on both sides. We have H2 plus O2 equals H2O as an example.
To balance them, to make the number of H2 and O the same on the left and on the right, I would add a 2 in front of H2O to balance the oxygen so that we have 2 oxygens on both sides. And now that I've messed up the numbers of hydrogens, I would go back and add a 2 next to H2 on the left-hand side, so that I have 4 hydrogens on both sides. And that's how you classify and balance chemical reactions. And just like that, you've learned all of Unit 1 in 10 minutes. If this helped you, please don't forget to like, comment, and subscribe so you don't miss Unit 2 Chemical Reactions and Stoichiometry coming soon.